Welcome back to Pi M Squared, and today we'll be going over the possible outcomes of compound events and how to find them. So first, before we start, we have to define one thing. The term is sample space, and sample space is basically just all the possible outcomes. Whenever you do something, it's all the possible outcomes. So for example, if you flip a coin, the possible outcomes are heads and tails, right? So your sample space would be heads or tails. But now we have to define what compound events are. Compound events are events, basically there's two events, more than one event. That's why they're compounded. So there's just more than one event. So for example, if I flipped a coin and then roll the dice, that would be a compound event. And then the sample space would be different if I flipped a coin, and then roll the dice. So in this video, I will be teaching you how to find out what the sample space is. So first, let's just get rid of this part. Okay. Sorry about that. So now there are multiple ways to do this, and the first way is called a tree diagram. So let's just say we're flipping one coin and one dice. Okay, so the sample space for this would start with either heads or tails. Now the dice has 6 options, right? 1, 2, 3, 4, or 5, 6. So after the heads, we draw 6 lines. 3, 4, 5, 6. So and then we go 1, 2, 3, 4, 5, 6. And we do the same thing with tails. So this tells you your entire sample space. So each line is one sample space. So H1, H2, H3, H4, H5, H6, T1, T2, T3, T4. So all of this combined is your sample space. So each of these is an option, and all your possibilities fall into your sample space. So if you say you flipped another coin, then each of these ones would have an H or T, etc., etc. So this type of tree diagram can help you when you're trying to figure out the entire sample space, because for each option, you can just add another little branch onto the tree. So now we will be going over a second example once we get rid of this. Okay, now we will be going over how to do it using a table. So we're going back to the same example, one coin, one die. So for this type of example, we would have heads here, tails here, and then create some kind of table like this. 1, 2, 3, 4, 5, 6. So the column represents the number of options for the coin, and the row represents the number of options for the die. And then all you have to do is just make a little grid. And then do those things that you did in multiplication tables in kindergarten, where you just draw a line from each one. So H1, H2, H3, H4, H5, H6, and so on, right? So this type of table can also help you get the sample space, but it's less helpful if there's like more than one. Say there's another die, how would you do that? So for that kind of thing, you probably might not want to use a table. So Now we're going to go over the final example of how you would find the sample space of a compound event. Okay, so your final way would be just a list. So this is the kind of brute force way of doing it, but hey, whatever works. So you have a coin and a die. Again, you make a list of all the outcomes. Oh, so it'd be H1, H2, H3, H4, H5, H6, T1, T2, T3, T4, T5, T6. Hey, there you have your sample space. So I'm sure you wouldn't want to do this when it gets really big. And it's all of these aren't very good at saving you time. But if you really want to figure out all your options, then you just have to do it, unfortunately. So today you learned about tree diagrams, tables, and lists to find the sample space of compound events. So sample space is all your options, the total possible event. Nothing that's out of your sample space could possibly occur. So you couldn't get an H7 because there's no 7 on the die. So, but everything that's in the sample space has a chance of occurring. Okay? Thank you for watching.